So today we will review some knowledge about maximum and minimum, right? Okay, and basically it's our lesson 9, and which is quite tricky. I guess you have experienced such a long lesson in that week, right? Okay, so and about these two lessons, about this knowledge, we actually have two mainly main parts of it. Okay, one is about forming numbers. One is about forming numbers. Do you have any idea what kind of problems that you may meet when you are asked to form some numbers? If you got certain questions in your mind, give me a thumbs up that you have met. So anything related to maximum and minimum, and it has something to do with forming numbers. Yeah, okay, I can see Liam and yeah, okay, hi Liam, Mia are giving me a thumbs up. All right, basically it's about you will be given some numbers, given some digits or maybe number cards, and you will be asked to form a number, maybe the largest possible number or the smallest possible number, okay, according to the given numbers. And when doing such kind of thing, okay, let's basically think about it. For example, let's take a look at what's given here. Okay, so for example, Sally has these number cards, 8, 5, 9, and 2. All right, 4 number cards. And what is the largest 3-digit number she can make? So basically, this is an example, right? Okay, so so now let's take this as an example. So when we need to decide or when we need to form some numbers, can you tell me what's the first thing that it will come to your mind to decide how large a number is? Okay, what may determine how large a number is? So, Hailey, you are raising your hand? Yeah, you can unmute yourself.
You can put the biggest number at the front.
Oh, very good. Okay, you mentioned something about what to put or which number to put in the first or beginning digit. Am I right? Okay, so if that if that makes sense for you, makes sense to you, I mean the beginning digit, how large the beginning digit is. If you do think the beginning digit may determine whether whether the number is big or small, so give me a thumbs up. Let me take a look at your response. Yeah, very good, very good. Okay, of course, this is a very important factor which may determine how large a number is, right? Okay, so and the second thing, another thing sometimes, okay, so but don't forget, for example, so tell me which one is bigger, 999 or 1000? Which one is bigger? Very obvious, am I right? So 199 is smaller than 1000, right? Okay, so now you can see the beginning digit is 9 and the beginning digit is 1. Even though 9 is much larger than 1, but still 999 is smaller than 1000. That's because what is different? What is different? Yeah, okay. Holly? Is that Holly? You can answer the question?
It's because there are more digits.
Very good. The number of the digits. Am I right? The number of digits. How many digits there are? So if you want to make sure, so in most cases, actually, you will be given a certain digit, like the question here. You can see. So you need to form a 3-digit number or 4-digit number. If that is fixed, then you don't need to think about that. But in some tricky problems, there will be no limit about that. Okay, and in that way, you need to take the number of digits into consideration. Okay, so basically there are two factors which may matter when we form a number. If this is clear, so give me a thumbs up. Yeah. Okay, so you need to take those two factors into consideration, right? Okay, so and of course sometimes you will be given more limits. Okay, so and that time we will take that into consideration, right? Okay, so now let's take a look at those questions. So the first one, we have 4 number cards And the first thing is about 3-digit numbers you can make, the largest one. Okay, so basically I will first go through the yeah, thank you for your answer, but during my explanation, maybe we yes, thank you. Okay, so just make sure, okay, everyone, during only when I ask you to make some notes on the screen. So in other cases, please don't make some notes on the screen. All right, so otherwise it will be a little bit too messy. Let me take a look. Yeah, I guess. Okay. So here, first for the largest 3-digit numbers you can make is, so basically we start from the first digit, okay, and to make it as big as possible, so which means it's 9, right? Okay, since it's number cards, so after using one number card, maybe you don't have that anymore, so which means for the second one, it should be the second largest one, which is 8. Right, very good. Okay, I can see some of your hands in the screen. Very good. Okay, if you would like to interact me with that, okay, that's totally fine. Okay, so for example, you can show me what's the next largest one. Yeah, very good. It's 5. Right? Basically, when we deal with this kind of question, we do it digit by digit. We do it digit by digit. Okay, just make sure if you list out all the options of all those digits, that can help you deal with the or make the right choice more carefully. Right, okay, so for the second one, it's not that difficult. The largest 4-digit number. Okay, the largest 4-digit number. So the process keeps the same. You start with the first digit, which is, so you can show me in the screen if you like. Very good, okay, I can see lots of 9 in the screen, very good. And then, next one, it should be, very good, this time I can find some 8, yes, very good, okay. So from large to small, right, like the descending order, so here, next one, it'll be 5, and final one, 2, right? So that's how we can make it. And then, if what we need to do is the smallest 4-digit number, okay, so then tell me which one should we begin with? What's the first digit number? Very good, okay, so this time we start from small to bigger numbers. So that's 2, 5, 8, and 9. Am I right? Okay, that's not that difficult, so I will just go through it very fast. Okay, so now let's pay attention to the final one. Okay, so in the former 3 lessons, in the former 3 questions, there are no more limits besides the largest or smallest, besides the number of digits, right? Okay, but in the 4th question, so what we need to do is to make a number between 7,500 and 8,300. Okay, and you need to use the number cards only. Okay, you cannot use any other numbers, right? So here it's kind of a limit. It's a kind of limit. So once, everyone pay great attention, once we have any limit, like the whether it's an even number or odd number, whether it is whether it is a multiple of 3, for example, or multiple of 4, something like that, we always start with the limit. Okay, so we always start with limit. Okay, so and here, since the limit is the range, how large this number should be. Okay, so I guess we should start with the first digit, because that determines how large the number should be. Okay, so is there any idea? You can tell me through the chat box. Okay, so and tell me what should be the first digit. Simply give me the first digit. The first digit. Very good, okay, because when you among those 4 number cards, okay, so 8 is the only choice which can make sure the numbers that we form could fall into this range. Am I right? Okay, so pretty good. So and the second one, it should be, can we use 5 for example? Can we use 5 for example? Nope, okay, because if we use 5, that would be larger than 8,300, right? So we should only use 2, right? Okay, and the next one, it should be make a number, so use only number cards. So it's not limited that whether it should be as large as possible or as small as possible. So yeah, very good. So next one we can say it should be 5, 9, or maybe 9, 5. Both are correct. Am I clear about that? Okay, so if this question makes sense, so give me a thumbs up. Yeah, okay. So let me do a very quick recap about what we should do when dealing with such kind of problem. Okay, so I don't know why the prepared notes is gone. Okay, can you see any notes on the screen? I guess not. Let me take a look.
No.
Nope, right?
No.
Okay. So what about this? Actually, I prepared some notes here, right? Okay.
Better.
Yeah, it's better, right?
Yeah.
Very good. Very good. Okay.
Better.
So next time, if you need to solve some questions related to forming numbers, remember, first decide how many digits there are in this number, okay? Because the fewer digits it has, the smaller the number will be. Okay, so make sure this is the first factor which will determine how large the number is. Second one is about the beginning digit. Okay, if you want to make a the biggest number, then you start with the biggest choice. If what you need to get is the smallest number, then you start with the smallest choice. Okay, but remember, can we put 0 at the very beginning? Can we use 0 at the very beginning? Never. Okay,
No.
so pay great attention to that. But very important reminder is some of the students may forget to use 0 in the second digit. Did that require memory of some cases? Maybe some of your classmates forget to use 0 in the second digit, right? Okay, pretty good. So just pay great attention. If you need to make a small number, then and 0 is a choice, one of the choice. Okay, so don't forget to use 0 in the second choice, in the second digit. It could make the whole number as small as possible. All right. So and then you need to take some other limits into consideration, like odd or even, like whether a number could be used twice or more, or maybe whether the number needs to be a multiple of something. Okay. So that's. Oh yeah. Now it's showed up. It showed up. Okay, so now in the following questions, I will go through the questions very fast, okay? If you get some idea, you can tell me through the chat box, okay? So, but you don't need to give me the question the answer so soon. Only when I say, please give me the answer or type the answer in the chat box, then you send it. All right, so let's try those things. So let's read the question together. So Crystal uses 5 digits 0, 1, 3, 6, and 7 to make up a 4-digit number. Pay attention, a 4-digit number. So if Crystal makes an odd number, and each digit can be used more than once, okay? Can be used more than once. So the smallest possible odd number Crystal can make is blah, blah, blah. Okay, so smallest odd number. Tell me, should we start with the first digit or should we start with the final digit? 1 or 4? Show me through screen. 1 or 4? Show me through screen. Yeah, I just mentioned it's better for you to start with the limit. Am I right? Okay, so odd number is a kind of limit. So we start with the final digit to make sure. Okay, we got enough choices when for those limits. So to make it odd number, then we have 1 or 3 or 7 as the choice. Okay, so and to make it smallest, to make the whole number smallest, then in the final digits, should we make it large or small? Yeah, okay. So some of you may want to use 1 in the final digit, but actually 1. Where should we use 1? Yeah.
Last.
Very good. Okay, I can see lots of you are trying, are using your camera to interact with me. Pretty good try. Okay, so for example, that's 1, right? Okay, so we need to use 1 in the first digit. So in this way, if we want to make it as small as possible, maybe we should use the bigger numbers in the final digit, like 7. Am I right? Okay, so and then that's so and in the first digit we should use 1, right? So what about the second digit? Which number should we use? We still have 0, 3, and 6. So show me through screen. Very good. Okay, I can see lots of zeros in the screen, right? Okay, pretty good. So don't forget to use 0 when you want to make the smallest possible number, right? Okay, and next one would be 3. So if some of you may be a little bit confused, like, why don't we use 3 in the final digit? That's because if you use the 3, then you have to use 6 or 7 in the, in the 10th, right? And that will be bigger than 37, something like that. Okay, so don't forget, what you need to do is to make the smallest possible number. So in this way, you need to make sure the smaller numbers could be used in some first digits, right? Something like that. Okay, pretty good. So that's the first one. And the second one, if Crystal makes up an odd number without repeating digits, then the smallest possible odd number. Oh, sorry. Oh, sorry. I just forgot something. Yeah. So for the last one, so that's quite important. That's quite important. Thank you for reminding me, and I suddenly realized that, right? Okay, so I guess some of you want to remind me of that. So pretty good. So now, since the digits could be used more than once, then we can use as smaller numbers as possible. So here we got 1, 3, and 7. So we use smaller choice, like 1, right? Okay, and then so for the tens, we can use 0 because it could be repeated, right? Okay, so it also so since if so as you can see, we need to take those requirements into consideration. That's quite important. Okay, so and for the next one, without repeating, right? For the second try, without repeating, and it's still odd, and it's still smallest. I guess our answer. That we come up with last time should be the answer to this question, right? Okay, so here you got 3 choices, 1, 3, 7, and you use the bigger one to make sure the smaller numbers could be used in the former digits, right? Okay, and then 1 for the thousands, 0 for the hundreds, and 3 for the tens, right? Okay, so does that make sense to you? Does the whole process make sense to you? If yes, give me a thumbs up. Nice. Very good. Very good. Okay, so sorry for forgetting something about using the digits more than once. Okay, so it's also a very good reminder for every one of you here. Okay, so even the teacher may miss some requirements like that. Okay, so we need to read the question very carefully. Okay, so and for the third one, so if Crystal makes up an even number without repeating digits, okay, and then the smallest possible number. All right, so and it should be the multiple of 4. So here we got lots of choices. Here, right? Okay, so let's pay great attention. So it's an even number and the multiple of 4. So I guess for the last one, we already have some choices, like it should be 0 or 6. Am I right? Okay, so and then you can take a look. So of course, for to make it smallest, we should use 1 in the first digit. And then in the second digit, usually we should use 0. Okay, but now this time we need to test a little bit, because if we use 0 and we can't form another multiple of 4, then it means we can't use 0. Okay, but if we can find some other multiple of 4 in the final 2 digits, that's totally fine. Am I right? So let's take a look. So can you find any multiple of 4 which ends with 6 and the beginning letter is 3 or 7? Any idea? You can type that in the chat box. You can type that in the chat box. Let me take a look. I give you 5 seconds to type it, and later I will see. 5, 4, 3, 2, 1. Let me take a look. Yeah, I can see lots of 3 and 6, right? 3 and 6. Pretty good. Because 36 is a multiple of 4. Right? 36 is a multiple of 4. So that's how we can test. Okay, so it's fine for us to use 0 in the hundreds. Right? Okay. So, but if we test, if after our test is, for example, we don't have 3, we have some other numbers. Okay. So, and that number with 6 at the end cannot be the multiple of 4, then that means we cannot use 0 at that point. Okay. So, but luckily this time, we got the correct answer. Okay, pretty good. So that's how we do it. Just remember, okay? So we take those things into consideration and we always start with the limits. That's fine. Okay? So, and the next one, let's move on a little bit faster. So still something about forming numbers, and Buzz wants to remove 2 digits of the 6-digit number 27465 and make it as small as possible. Okay, so which 2 digits should she remove? Okay, so I will set a 30 seconds timer, and I guess that's enough for you to think about it. After 30 seconds, you can type your answer in the chat box. Okay, before 30 seconds, before time's up, please just think. It's almost the time. Get ready to type your answer in the chat box. Let me see. Aha. Okay. So here, for this question, actually, we need to think about it very carefully, okay? Because we need to make sure the whole number is as small as possible, right? So, which means those 4-digit number, what should be used as the first one? What should be used as the first one? Okay, you can type that in the chat box, or maybe you can show me through screen. That's both fine. Which number should be left for the first digit to make it as small as possible? Very good. It should be 2, right? Because all other 4 numbers, like 7 as the digit, 4 as the digit, all other numbers as a digit, it should be bigger than 2, right? So, and then for the second number, of course, we want to use 3. Am I right? But can we use 3? Can we use 3? Yes or no? Yes or no? No, we cannot use 3. If we use 3, that means we change the order of that original number. Am I right? Okay, so pay great attention. We simply remove 2 digits. It doesn't mean we can rearrange the order of those digits. Right? Okay, so we cannot use 3 because that's the final digit. Right? Okay, so and then you can see the next one, it should be 4. Can we use 4 as the second digit? Yes or no? Can we use 4 as the second digit? Yes, because we only need to remove 7 to make it the second digit. Am I right? Okay, so in this way, we know the first thing we need to remove, the first digit we need to remove is 7, right? And then let's go on. So in next digit, we still can confirm that 3 is not possible, even though it's the smallest number. okay, because it's at the final digit, so we cannot use it. So then, for 6 and 8, which one should we use? Which one should we use to make it as small as possible? Very good. We should use 6. Right? Okay. This is how you get 6. And actually, maybe yes. Forget about it. You can type it in the chat box. Yeah, 6. So, and the final digit, of course, we can use the smallest one. Finally, here it comes, 3. Right? And in this way, it means that we simply need to remove 7 and 8. 7 and 8. Right? Okay. So if you think it's quite clear about the reasoning, about the whole process, how we can work it out, if that's clear enough for you, give me a thumbs up. Okay. Thank you, Jason. Thank you, Colino. Okay. Yeah, very good, very good. I can find lots of thumbs ups there. Okay, pretty good. So basically, for that, the former 5 questions, the former 4 questions are all about forming numbers. Okay, so and that's our first part of minimum and maximum topic. Okay, so but more importantly, or maybe more difficultly, is the second kind of question, which has something to do with some real minimum and maximum questions. Okay, it's about distribution. Distribution. All right. So distribution. Since you have finished the lesson 9, I guess most of you, and you have worked on some of those questions. So basically, you in such distribution problems, you will be asked like, we got a total number of apples or maybe stories or whatever it is. We have a total number of it. And then it needs to be distributed to maybe or among a certain group of people, like 8 people, like it should be finished in 5 days, whatever it is. Or maybe some chocolates need to be put in some boxes, whatever it is, okay? It means a sum of something needs to be put into several different parts. That's the reason why we call it distribution problem. Does that make sense to you? Okay, so something about the background of certain kind of question, right? Okay, distribution. And in this kind of distribution, actually, we have we have 4 different ideas. Okay, 4 different ideas. Let me take a look. Okay, so let's take a look. We are clear about maximum and minimum. Am I right? Okay, but in the questions, sometimes you will meet the problems like for the child who gets the most, what's the least number that he can get? Am I right? In that way, actually, it's not simply maximum. It's the smallest maximum. The smallest maximum. Does that make sense to you? The idea of smallest maximum, right? Okay, so in the reverse way, we also have the largest minimum, right? The largest minimum. So if it's a little bit too abstract to you, okay, so we can just take maybe the number of the things. So like we are going to share something, right? Okay, so and let's take a look. Let's suppose this is the largest number, which is the maximum, okay? And they are maybe the minimum or whatever they are, okay? Or others. So when it's simply the maximum, then it should go as high as possible, and all others should go as low as possible to make it maximum. Does that make sense? Does that make sense? If you want to make sure that my fist go as high as possible, you need to make sure my arm go as low as possible to make the sum unchanged, right? Okay, but when it's the smallest maximum question, tell me what happens when my fist goes down. If my fist goes down, what may happen? You can show me your fist and your arm to show me the process like that. if your fist, the maximum becomes smaller. Ah, very good. I can see Mia. I can see Li Jiang. Very good. Okay, I can see Michelle. Right? Okay, very good. Lots of you. Lots of you. And Holy, right? Okay. So Lucy, very good. So it means your arm needs to go up because the sum remains unchanged. Am I right? Okay. So that's how we can get it. So which means when a certain number gets the smallest maximum, then all others should be as close to the smallest maximum as possible, which should be the average. Am I right? How can you make sure all other numbers are as close to the smallest maximum as possible? Then we think about the average. Okay, so let's take a look at, for example, so if we got 21 apples and there are 4 groups that you need to divide it into, then the smallest, smallest maximum would be 21 divided by 4. We get 5 remainder 1, right? And then it means 5, 5, 5, and for the smallest maximum, it gets 6. Am I right? Okay, so and that's how 6 is that fist, and all others, the arms, okay, my arm are all those 5, and when they get as close to each other, actually it means they are very close to the average number. Okay, if the idea or the concept or the reasoning about the average number makes sense to you, give me a thumbs up, because that's the key point for you to understand how you work out those questions. Okay, pretty good, very good. Okay, I can see lots of you raising your hand and giving me a thumbs up, right? Okay, so now let's take a look at those questions, right? So for example, the first one, remember, actually we have two different conditions. One condition is about you are simply want to be as big as possible. That means your fist goes up and all others goes down, right? Okay, that means the extreme condition. And the second one is called average condition. This is when you need to figure out the smallest maximum or the largest minimum. Okay, so let me do a very quick note for you, right? Okay, if it's extreme condition, okay, so the fist should go as high as possible and the arm should go as low as possible, right? Okay, so that's how it works. So and then that's something about maximum and the minimum. And the second thing is about the average condition. Okay, so and that's when the fist and the arm are very close to each other. Okay, so we use this kind of condition in when we need to figure out the smallest maximum or the largest minimum. All right. Okay, so now let's take a look. We need to decide what kind of condition it is. Okay, so 120 apples are distributed among 5 children, and each of them can get at least 1 apple. Okay, that's quite important, kind of limit. So no 2 children get the same number of apples. No the same, all right? So it means all different. So for the kids who gets the least apple, what's the least possible number of the apples he or she can get? So tell me, is it the condition 1, extreme condition, or is this the second condition, which is average condition? Tell me 1 or 2. Kid who gets the least apples, what's the least possible number of the apples? Extreme condition or average condition? 1 or 2? Okay. Pay attention, it's 1, extreme condition. Okay, because that's something, the least apples, it means he gets the least. It's something like the arm, right? And what's the least possible number? It means it's smallest. the smallest minimum, it goes as low as possible. Does that make sense? If yes, give me a thumbs up. Yeah, it's the smallest minimum, okay? So it should go as low as possible, right? So that's extreme. Okay, so now let's take a look. What's the least possible number? Since they at least get 1. So, which means the smallest number of it is 1. Am I right? Am I right? And now, actually, this is the answer to the first question, because you don't even need to think about all others. That is the smallest minimum. Am I clear about the first answer? Right, okay. It may be a little bit too quick, right? Okay, but that's true. The least smallest answer is 1. Okay. So, and for the second condition, let's take a look. So, for the kid who gets the most apples, pay attention, it's the one who gets the most apples, which means it's the fist. Okay? What's the largest possible number? What's the largest possible number of the apples he or she can get? Think about it. Is this extreme condition or average condition? 1 or 2? Extreme condition, 1. Average condition, 2. Think about it. It's the fist. And it needs to be largest. 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 Very good. I can find more ones on the screen, okay? More ones on the screen. Very good. Pay attention. The largest number who gets the most should be as large as possible. Then that means it goes to the extreme. Does that make sense? Does that make sense to you? Right. Okay, pay attention. It's still the condition 1. So, if you want to make sure this is the largest, for example, children 5 gets the most. Okay, so what we need to do is to make sure all others get as few as possible. Am I right? All others get as few as possible. So could it be 1, 1, 1, 1? Is it possible? Yes or no? Very good. I can see lots of you shaking your hands. No, it's not. Right, okay, because all numbers needs to be different. So it should be at least 1, 2, 3, and 4. Am I right? And you can find the sum of 1, 2, 3, 4 is 10. Okay, so, and for the final children who gets the most, it should be the total number 120, take away 10, which is 110 apples. That's the answer. If it makes sense to you, the whole process makes sense to you, give me a thumbs up. Yes. Okay, pretty good, pretty good. So,
I have a question.
Oh yeah, sure. Okay, so is that hacker?
Yeah.
Okay, yeah. What's your question?
I don't think it's correct because a child can't eat 110 apples.
Why? Why not? What's wrong?
It's unrealistic.
What? Sorry, I didn't get that.
It's unrealistic.
Oh, you mean it's a little bit unrealistic, like to have someone getting so many apples, right? Okay. So, but even though maybe in the real life it's not realistic, but that's the answer to this question. Okay. As long as the calculation or the process isn't wrong, that's fine. Okay. But yeah, of course, in our real life, sometimes maybe when we need to share things, we want to share that as evenly as possible. That's totally fine. All right. Okay, so no more questions? Any questions? All right, let's take a look at the next one. So I will ask you this question, okay? After reading the question, you need to tell me whether this is an extreme condition or it's an average condition. All right? Okay, so 88 pieces of candy are shared between 8 children, and each of them get at least 1 piece. No 2 children get the same. It means all different. So for the children who gets the most pieces, what's the least possible number of the pieces they can get? So type in the chat box whether it's the extreme condition, which means 1, or the average condition, which means 2. So I'll give you 5 seconds to think about it. So for the one who gets most pieces, what's the least possible number of it? The one who gets most, what's the least possible number of it? Okay, now type your answer in the chat box. Ah, very good, very good. Nice, all correct, very good, okay? It's an average condition. It's an average condition, okay? Right, because just think about it. Next time, if you need to solve this kind of question, just put a fist and your arm into your mind, okay? So and just think about it. If they get very close to each other, the one who gets most and what's the smallest number of it, it means they are very close to each other, and this is the average condition, right? Okay, yeah, I can find lots of fists in the air, right? Okay, so very good. So in this way, since it's an average condition, now you can do things. Actually, I would like to show you two different methods. I will show you two different methods. One is the thing which I show in my class, okay? Another one is some like a listing method, very close to listing method, okay? You can choose which one you would like to take, okay? So since it's average, so let's do it like average. 88 divided by 8, which means 11. That's the as average as possible. Am I right? So let's do 11 like this. But is it reasonable for this question? No, because no two different children get same number. It means, but now it's all children get the same number, right? Okay, but how to make it different? How to make it different? So you can think about it. It means, we can, for example, like this, okay? When one of them take away, means like maybe one step down, okay? So the others can get one, which means one step up. Am I right? So as long as we keep the adding and the subtraction the same, the total number would be the same. Right? Okay, so let me show you something like that. Okay? So for example, you take away 1 from 11, then you add 1 from 11. Does that make sense to you? The total number doesn't change. Right? Okay, but those two numbers becomes different, right? And then you do a little bit more. You do a little bit more. You do a little bit more. Right? Think about that. Think about that. It becomes 7, 8, 9, 10, 12, 13, 14, and 15. Right? Okay. So in this way, actually, you can see they are as close to each other as possible, but no, not the same. Not the same. Am I right? If since there are 8 children, this is an even number, so we do things in this way. But if there is like 7 children, then there will be an 11 in the middle. So we start from 2 different ends, right? Okay, so this is one of the way, and in this way you can get the answer like 15, like 15. Okay, but it depends. Maybe if there are more children, like 88 children, then it's I don't think it's reasonable for you to use this kind of method, right? Okay, because it will be too difficult for you to write down all those numbers. Okay, so the second method would be, okay, so let's take a look. This is for the method 1. Okay, it's like listing method. Listing method. All right. The second method is what I call one-for-all method, because it can be used in all different conditions. I mean, in all different average conditions, right? Okay, but it's a little bit difficult for you to understand, and maybe it involves a little bit more steps.
Yep. I have another question.
Yes.
What's the biggest the biggest least?
The biggest least. What do you mean the biggest least? Is that the largest minimum?
Yeah.
Yeah, okay. So let's first focus on what we need to figure out for this question. All right. So later we will talk about your question because now this time we are talking about the smallest maximum. Am I right? Okay. So next time we can talk about the largest minimum. Later you will also see it. Okay. So basically the largest minimum is 7, as you can see here in this condition. The part because when the maximum reaches the smallest, then the minimum must be the largest, because they are very close to each other, right? Okay, so that's the largest minimum. Okay, but now let's move on to the second method. Okay, so I will complete my explanation about the second method first, and you try to follow my reasoning part. Okay, so here, so since all those people, all those children get different numbers of candies, so at least the number of the candies they get is 1, 2, 3, 4, 5, 6, 7. Sorry, yeah, I missed the 6. 6, 7, and 8. This is we can regard it as the base number, right? At least they need to get those numbers, okay? But of course, we know that 1 and 2 and 3 and add up to 7 and 8, it equals 36. Okay, I just skipped the calculation part, okay? But I know the answer is 36. Okay, so, but actually what we have is 88 candies, right? So, which means we still have 52 candies left. And for those 52 candies, since it's an average condition, we need to divide it, or we need to distribute it as evenly as possible. So we use 52 divided by 8. We get the number 6, remainder 4. Am I right? Okay, so for this 6, as you can see, this is the average. This is the average number, because after adding the same number, like add 6 and 6 and 6 for each of those numbers, actually it won't, they should always be the different, right? Because the base number is different. Okay, so, and but we still get something to figure out. We still get 4 remainders, am I right? So we call it extra. We call it extra. So for those extra numbers, how can we divide it, or how can we distribute it? Can we distribute it to the smaller numbers to avoid the maximum become larger? We can try so. For example, if we give 1 to children 1, what happens? What happens? You can see he will get 8 candies, and then there will be two same numbers. Am I right? Which means if we give the candies to the smaller numbers, it doesn't work. So tell me, in this way, in this kind of thinking, we know actually for those extra or remaining ones, we should give them to the biggest ones. Because only in this way can we avoid some repetitive numbers. Okay? So, and in this way, we can exactly get the same answer. That's 7, 8, 9, 10, 12, 13, 14, 15. Exactly the same. Am I right? Okay, so the reason why I say this method is like one for all is because if you don't understand, that's still fine for you. You can just repeat this kind of steps: listing, doing the average, distribute the extra. That's how you can get to the answer, right? Am I clear about that? Okay, if it makes sense to you, give me a thumbs up. Okay, so any method makes sense to you, that's totally fine. All right, so the method 1 or method 2, both fine, both fine. All right. Okay, so we will use this kind of method in the following questions. All right. So so here you can see the total of 6 different positive even numbers is 96. What's the most that the largest could be? The largest number could be. So think about it. Is it a kind of extreme condition or average condition? Think about it. What we need to figure out is the most and the largest number. 1 or 2. 1 or 2. 1 or 2. What's the most that the largest number could be? The most and the largest. The most and the largest. Is it extreme or average? Average is something like this. Extreme is something like this. Okay? Type 1 or 2 in the chat box. Give you 5 seconds to think about it. Let me take a look. Oh, nice. 1, 1, 1, 1, 1. Oh, suddenly I got 2, but mostly it's 1. Okay, very good. It's extreme. Think about it. The most and it becomes largest. It means the fist goes up as high as possible. Am I right? Okay, so it's extreme. So when it's extreme, actually it's very easy. The extreme condition is very easy. You just make sure if you want to get the maximum, then all others be as small as possible, right? So tell me, what's the smallest positive even number? What's the smallest positive number? That would be 2, then 4, then 6, then 8, then 10. Am I right? The smallest 5 even number, a positive even number, are them. Okay, so and when those 5 numbers are there, then the 6th one should be as large as possible. Am I right? Should be as large as possible. And they all add up to 96. So in this way, we can see those 5 numbers add up to 30, I guess. Yeah. So the maximum equals 96, take away 30, which is 66. 66. Does that make sense? One more time, okay? So we are talking about a total of 6 different positive even numbers. And what you need to get is the largest maximum, which means as high as possible. So you need to make sure all others as low as possible, right? So we just list out the smallest 5 positive even numbers, which is 2, 4, 6, 8, 10. Am I right? Okay, so they are the smallest one. And then we can get the sum of those smallest one is 30. So the biggest number possible is 96. Take away 30, which is 66. So you choose boy. Make sense to you? Yes or no? Whether it makes sense to you. Okay, so we can recap a little bit. Okay, we can recap a little bit. So far, as you can see, the first question, whatever the question is, okay, but our first thinking step is to decide what condition it is, whether it's an extreme condition or average condition. Okay, so that's the first step. The second step is use different method to when we decide whether it's extreme or average. Okay, if it's extreme, then you just need to make sure all others be as small as possible, or maybe all others be as big as possible, right? Something like that. But what's a little bit more difficult is average condition. Okay, and in this way you can use such kind of method. Okay, method 1 or method 2, both are fine. All right, so now let's take a look. Continue. So here, it's a real 11 plus question. Okay, so the mean of 4 different, pay attention, the mean, which means the average. So the average of 4 different positive odd numbers, different positive odd numbers is 6. Okay, so tell me. So this is quite interesting. This is quite interesting. Can you tell me, do we know what's the sum of all those 4 numbers? What's the sum of all those 4 numbers? If you know the sum of those 4 numbers, type that in the chat box. Type that in the chat box. The question only tells us that the mean of all those 4 different positive odd numbers is 6. By knowing this, can we work out what's the sum of them? Think about it. Think about it. What does average mean? How can we get average? What do we need? And in the reverse way, what can we figure out? All right, let me take a look at the chat box. I can see Connie, Michelle, very good. Okay, Holly, Oscar. Yeah. Okay, pretty good. Hacker, Olivia. Yeah, lots of you got the answer. Pretty good. Okay, so think about it. The sum divided by the numbers, the number of numbers, equals the average. Am I right? Am I right? Okay, for example, 4 numbers, and the sum of them are, whatever the number is, the sum of them are 24. Then you know the average of those 4 numbers should be 6. Right, which means the sum equals average times the number of numbers, right? Okay, so here it should be 6 times 4, and that's 24. Am I clear? So this is the first trick part, even though I don't think it's a very difficult trick, but sometimes you will get stuck here. Okay, so pay attention to this. So and let's move on. So we need to take a look. What's the least amount that the largest number could be? Oh, here comes the question. Is it an extreme question, or is it an average condition? Think about it. What's the least amount that the largest number could be? 1 or 2? Type that in the chat box. Type that in the chat box. What's the least amount of the largest possible number could be? Could be. 5 seconds. Think about it. The largest number and the least amount. Yay, great. Great. It's an average condition. Pretty good. Okay, it seems that you absorbed quite well today, right? Okay. It's an average, right? So, yeah, but I can still find some of you a little bit confusing, right? Okay, so it's totally fine. It's totally fine because maximum and minimum, this topic could be truly very confusing, right? Okay, so another way which may help you a little bit is when you read the question, okay? So if you read something like most, you put an arrow, upwards arrow, okay? So maybe the largest, it's also arrow. But if it's least, you put a downward. And if it's the smallest, it's downward. Okay? So as you can see, if it's 2 same arrows, like 2 upwards arrow, or that means it's maximum. And if it's 2, downwards arrows, it means it's minimum, right? And in those conditions, they are extremes. You can see because it goes up. It always goes up. So that's how we can decide whether it's an extreme, right? But if you can find 1 upwards and 1 downwards, or maybe 1 downwards, 1 upwards, then it's something like being average. Right? Okay, so sometimes going up, sometimes going down, right? So things like that. Okay, so it can help if it's still a little bit confusing to you, right? Okay, so now let's pay attention. So here, since it's the average condition, then we can start with this. Okay, so since we know it's 24, and let's put it 6, 6, 6, and 6. So that would be the method 1, right? Okay, 6, 6, 6, 6, that's the method 1. And then we can say, so pay great attention. It's odd number. So can we do something like take away 1 and add 1, take away 2 and add 2? Can we do something like this? Yes or no? Why not? Because this makes it even. Am I right? Okay. So pay great attention. Pay great attention. We can do take away 1 and then plus 1, but we can't do take away 2 and plus 2. What we should do is take away 3. Right? Okay, very good. I can find 3 in the screen. So take away 3 and plus 3. That's how we can make sure all those numbers are odd numbers. Am I right? Okay, so in this way we get 3, 5, 7, and 9. Okay, and the least amount that the largest number could be should be 9. So this is method 1. Okay, we list them out and do slight changes, and we get the answer. Okay, so it works when the total number of the numbers are small. Okay, like 4 numbers, 8 numbers. I guess 8 could be the most, right? So and for the second method, I would still have a try. So since there are four different positive odd numbers, so the smallest positive number should be 1, 3, 5, 7, right? So they are the base number. And in this way, we can see 1 add 3 add 5 add 7, it equals 16. So which means 24 take away 16, we still have 8 left to arrange. Am I right? And 8 divided by 4, it means all those 4 numbers could get 2 for average. So the second part would be average number. For average number, each of them can get 2. So that's the 2, 2, 2, 2. And because here we don't have any remainders, so that means no extra numbers. So that's the end. It's still the same, like 3, 5, 7, and 9. Okay? So in both with both methods, you can work out the right answer. Okay, it should be E9. Does that make sense to you? Yes? Okay, pretty good. Pretty good. Yes. So great. Okay, I actually wish that this is a lesson delivered in the platform, so I can send you some red packet. Okay, but sorry, I can't send you red packet now. I only can send you some hug or some emoji, something like that. All right. Okay, but actually, well done. Well done. So and this is the final. Yeah, this is the final question. Okay. So maybe you can decide whether you would like to do that alone, right? So Jolene has a total of 35 sweets in 6 bags. Each bag contains a different number of sweets, and the 6th bag has the, so let me circle out all those important information. Okay, so it has the most number of sweets. Okay, so which means this is the maximum. All right, so what's the least number of the sweets that the 6th bag can possibly have? The 6th bag has the most. All right, so the same question. 1, is it an extreme question or is it an average question? Think about it. Think about it. 1 least, 1 most. Think about it. Think about it. Think about the arrows. Think about the fist and arm. So type your answer in the chat box. Get ready. Get ready. I can see very nice pose in the screen. Yeah. Very good. Lots of 2 sent by the same person, right? Okay. Pay great attention. It's 2. Very good. It's 2. Just remember. Okay. I just mentioned, when you have a most, you give me a upward arrow, right? Okay, so and when you have a least, you give me a downward arrow. Then if you have two arrows, pointing at the different direction, then it is the average condition. It can help you to understand it better or maybe make a wiser decision, right? Okay, so since it's an average condition, we can do that in this way. So 35, with the method 1. Oh, so what about this? For the final question, I will give you some individual thinking time. Okay, so I guess 1.5 minutes. If you are clear about the method, you can use that. Okay, 1.5 minutes can help you finish most of those process. Okay, so after 1.5 minutes, I will start my explanation. And if you have already figured out the answer in the given time, you can, of course, type your answers in chat box. Very good. Okay, it's almost about time. If you have already got the answer, you can type that in the chat box. All right, let me take a look. It seems that some of you got the answer. Okay, so it seems that you may have some different numbers, right? Okay, but I can find the correct one. Okay, pretty good. Let's do it. All right. So for example, with the first method, you can see 35 divided by 6, it should be 5, remainder 5, right? Okay, it means 5, 5, 5, 5, 5, and 5. Okay, so and you later don't forget to give some extra to those 5. So basically, you can see it's like adding take away 1, add 1, take away 2, add 2, take away 3, add 3. Okay, in this way, you can have 2, 3, 4, 6, 7, and 8. But you still have those 5 remaining. Don't forget about that. Okay, so and now you need to decide where you can give those 5 remaining sweets to. Okay, or who you can give those 5 remaining sweets to. So for example, definitely you can find there is a missing 5 here. So we can give 1 to, I will use another color to stand for the remaining one, okay? Remaining one. So definitely we can have 1 here, right? Okay, so and in this way, for example, we can, you can find it's a little bit tricky for you to arrange those candies. Like if you add 1, and add 1, then it goes to 3, 4, 5, 6, 7, 8, right? And when it comes to this, that far, we still got 2 remaining candies. Can we still give the candies to the smaller numbers, if at this time you can figure out actually we can't give those extra candies to the smaller numbers, because if we give, for example, one candy to the bag 1, then it will be 4, and those 2 bags contains the same number of the candies, right? In this way, we can only give candies to the bigger ones, which means get 1 here and get 1 here to avoid repetition. Am I right? To avoid repetition. And that's how you can get 8 and 9. In this way, 9 is the answer. Right? Okay, so this could be a little bit tricky part for you to arrange those extra candies. Okay, so but of course we have another method. Okay, starting from the method 2. So let's take a look. So, and for the method 2, we always start with, as long as it's different number, we start with 1, 2, 3, 4, 5, 6. All right, so that's the base number. And you can see 1 add 2 and all the way to 6, it equals 21. And 35 take away 21 is 14. So, which means for each of those 6 bags, they can get 2 for average and still remaining 2. Am I right? Okay, so now what we can do is to arrange those 2 to them. That's the average part. So add 2, add 2, add 2, add 2, add 2, and add 2. Right? Okay, so and the final round would be the way to distribute the extra 2. So for the extra 2, you will find it very easy, okay? Because in all the situations like this, we know we should start with the largest number to avoid the repetition, right? So in this way, you can still get the same answer. That's 9, 8, 6, 5, 4, and 3. Still the same. Still 9. All right. Okay, so 9 is the correct answer. And tell me who got the correct answer by yourself. Before my explanation, give me a double thumbs up. Double thumbs up. Woo. Nice. Okay, but it's totally fine. If you still maybe if you find a little bit tricky here or whatever, you can watch the playback, because in this very limited time, okay, so we need to finish all those 9 questions. That's a huge task, right? Okay, you already did a very good job if you can follow part of them. Right, okay, so for the final summary, okay, you have some I have already listed some word describing summary, okay, or maybe with my own writing, so you can take a look at I don't know. Oh yeah, here it comes, right to the point. Okay, so when you have this kind of distribution problem, so what you need to figure out, you need to pay great attention. We always start with what condition it is. Is it the extreme condition, or is it the average condition? Okay, in those 2 conditions, we use different method. All right. So and then when when you are talking about the same, try to solve the question. Okay, if the numbers could be the same, you directly use the average. Okay, something like that. Or maybe if it's the extreme condition, then you just simply go for the extreme, like what I mentioned here. Okay, so but the most difficult one would be the adding thing. The method 2, something like that. When the numbers should be different and it's still average condition, that will be the tricky part. Okay, hope today's revision session helped you understand this topic better. All right, so any questions? Any questions for today's answer? For today's revision? If yes, you can, just unmute yourself and ask. Give you 5 seconds. If no more
Bye.
questions, okay, bye-bye. Bye-bye today. Hope to see you next time. Bye-bye. Did a very good job. Bye-bye.
Bye.
Bye.
Bye. Bye-bye.
Bye.
Recording stopped.